Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today's topic is a new one. We are going to find out a Laplace transform periodic signals, and this was the first numerical. But before moving to problem number 1, there is one thing that you should know before solving or while solving numericals related to periodic signals. Now, what I mean by periodic signal? Periodic signal means what? A function repeats itself after a particular time interval or time period, which means if you apply limits on that function, then, or you can say if we apply limits on the first period, only on the first period, then a Laplace transform of first period signal repeats after a particular time period interval or a same interval. What I want to say is the function value repeats itself after a given time interval. Means what? A Laplace transform of first period is also similar to the Laplace transform of next time period. So it is not necessary to find out a Laplace transform whole stream or the whole periodic signal, which is started from minus infinity to infinity, or maybe it will be started from 0 to infinity. Only find out a Laplace transform of first period, so that we'll get the idea what is the result. And according to the formula, you can say that why the first part Laplace transform is important. And this formula is actually we have studied in the properties, which is a Laplace transform periodic signal. So first of all, we will solve a problem number 1. Now, the problem number 1. The question is determine Laplace transform of wave, or you can say a waveform, or you can say a plot, which is shown in figure. Now here we can say that it is nothing but a simple square wave, and here the period of square wave is t. Now you can say that this graph from which varies from 0 to t, or just concentrate on plot which is in between 0 to t. The same plot repeats from t to 2t, and this will be continuous till infinity. So that's why I'm saying it is not necessary to find out a Laplace transform given graph. Only find out a Laplace transform first period, which is started from 0 to t, because the same Laplace transform value will repeat itself after a time period. So first of all, we'll study a definition or the statement of periodic signals. We'll write the statement of periodic signal, and then we'll move on to, we'll find out the function value which is exist in between 0 to t. Now, basically, first of all, the statement of a Laplace transform periodic signal. X of s means what? A Laplace transform whole function or whole periodic signal. And it is nothing but only find out a Laplace transform of first period, that is 0 to t. And here the function or signal present in between 0 to t is represented by x1 of t. Only find out the Laplace transform of first period function, or the function which is present in first period, and it is represented by x1 of s. So for that, first of all, we have to find out equation for x1 of t. So x1 of t, sir, look at here. Here the x1 of t is having two different amplitudes, because look at here, this function is a periodic. Periodic means what? It completes its one cycle after a t. So what will be the value perfectly when it completes the first half cycle? As the complete cycle value is t, so half cycle value is t by 2. So this value is t by 2. Then this will be a 3t by 2. Now, so move on to x of t. We have to find out x1 of t first. x1 of t means what? The function value which is exist in between first period, or you can say in between 0 to t. So in between 0 to t, the x1 of t changes its value twice. So in first case, it is having amplitude a. This x1 of t, this part is the x1 of t. Now in this part, the x1 of t is having amplitude a when the time period is in between 0 to t by 2, and it is having amplitude minus a in between t by 2 to t. So I'm going to write here amplitude is minus a when the time period is moving from t by 2 to t. But basically in this formula, this t value, this time period value is important. Look at here, the time period value is represented by t, so no need to replace this t. If the number is mentioned like 0, 1, 2, then this t value will be a 2. But right now all the period value is represented by in terms of t, so no need to replace, we'll place the same value as a t. Now according to formula, first of all we have to find out the Laplace transform of x1 of t only in between 0 to t. So a Laplace transform of x1 of t is represented in Laplace transform by x1 of s, and the definition is 0 to t x1 of t e to the power minus st dt. And we know that in between 0 to t, x1 of t produces or changes its value. In between 0 to t by 2, it's having amplitude a, and from t by 2 to t, it's having amplitude minus a. So according to that, this integration limit will be also changed. So x1 of s is from 0 to t by 2. x1 of t is having amplitude a into e to the power minus st dt, and from t by 2 to t, the amplitude of x1 of t is minus a into e to the power minus st dt. Now look at here the a and minus a is the constant part, so we can take it outside from this integration. So we have a into bracket, or we can say integration, we'll start from 0 to t by 2 e to the power minus st dt, and after taking minus a outside, so this sign will be changed, which will be minus now, and integration limit is t by 2 to t e to the power minus st dt. Now apply integration on e to the power minus st. Now what you will get, the x1 of s is, after applying integration, what you will get, a is the constant part which was I have taken outside. Now we have e to the power minus st whole divided by actually the variable was t and the constant term is minus s, so minus s will be placed in denominator, and the time interval is from 0 to t by 2. Then we have minus a, and in bracket what we have, e to the power minus st again, and the integration of e to the power minus st is again e to the power minus st whole divided by minus s, and the time limit is start from t by 2 to t. Now look at here, in both the parts the a is common, so I'll take a outside and I'll substitute the values of t. Upper limit will apply first or comes first, and then we'll place minus sign, and then I will substitute lower limit. So one more thing, here also denominator part, in the denominator we have minus s, so I can take minus s common. So what you will get, minus a by s. Now substitute upper limit and then lower limit. So upper limit is e to the power s into this t is replaced by t by 2, so we'll write minus s t by 2 minus, we'll substitute 0, so this t is replaced by 0, so whole power becomes 0, so we have e to the power 0 minus, this is the minus sign. Now we'll substitute the upper limit first, so we have e to the power minus s, this t is replaced by capital T, minus e to the power, this t is replaced by t by 2, so we have e to the power minus s t by, so minus a by s. Now I will open this bracket so that this term will be minus and this term will get plus sign. So what you will get, e to the power minus s t by 2, e to the power 0 is always 1, minus this term will be having minus sign, e to the power minus st, minus minus become plus, so this will be e to the power minus s t by 2. Now look at here, e to the power minus st, e to the power minus st, So this will be a twice of e to the power minus st by 2 minus 1 and minus this term e to the power minus st. Now if you want, then you can take this minus sign inside this bracket or else keep it outside. Now I am multiplying this minus sign inside this bracket. Now I am multiplying this minus sign inside this bracket. So what you will get? This term will get minus sign, but remaining two will have a plus sign. So I'll write first 1, then why I have written 1? There is not any reason. There is no more any reason. So next, minus sign is multiplied with minus 2. So we have minus 2 e to the power minus st by 2. Minus sign is multiplied with this term, so this will be positive. And this is our x1 of s. Now according to the formula of x of s, what is important? x1 of s whole divided by 1 minus e to the power minus s into t, where the time period value is t, so no need to replace it, only we have to substitute x1 of s value. So this is nothing but a by s, in bracket we have 1 minus twice of e to the power minus s t by 2 plus e to the power minus st whole divided by 1 minus e to the power minus s power t. Now we can take this s in numerator, so therefore my x of s is now a, inside this bracket we have 1 minus twice of e to the power minus st by 2 plus e to the power minus st whole divided by s into 1 minus e to the power minus s capital T. And this is the result of a square wave, a continuous periodic square wave. So similar things we are going to solve in next videos also. So thank you for watching this video. Stay tuned with Ekeeda and subscribe for Ekeeda for further more videos. Thank you so much.